Hi, this is a tutorial for Multisim Live, which is the free online circuit simulator we're going to be using for a lot of the labs in this class. So you can go to multisim.com, use your student email address to create a student account, and once you've done that, I can walk you through how to create your first circuit. So to do that, come up to the top right where it says Create Circuit, and that is going to load a page. Let me zoom up on this so you can see. Now over here on the left hand side you can see a bunch of menus with circuit components. So what we're going to do is we're going to just build a very basic series circuit with one power source and one resistor. So first thing, let's grab a power source. The third one down from the left says sources, and let's just grab a DC voltage source, the one that with a symbol for a battery. Now when this drops on the page, by default it'll be named V1 and have a value of 12 volts. If you want to change that, all you have to do is just double click and you can type in any value here that you want, but just to start with we'll use the default value. Next we want to grab our resistor. So over here, the fourth one down in the menu is called passive, and the first choice here is the resistor. This is going to drop into your page by default in the horizontal orientation. If you want to flip that, all you got to do is just press this rotate button. And I'm going to slide this down. And then we want to connect these two circuit components together. So to do that, you're going to hover over one of the terminals until this spool connector appears. Left click once and that will make a wire, and you can just pull it on over until it connects with the top terminal of the resistor. Now you see there is a circle that appears. That lets you know that when you left click, that's going to establish a solid connection. This is a little bit temperamental. If you pull wires over somewhere close to a terminal but it doesn't make that circle, it's possible it might not make a connection and then your simulation won't work. So let me just pull that up for aesthetics. Now we want to connect the bottom side of the voltage source to the bottom side of the resistor. So I will just use that spool connector again. And now we have a completed circuit. The last thing that we have to put in, and you need this in order for the simulation to run, is you actually have to designate a ground node. So to do that, over here on the left hand side, second one down is called schematic connectors. So click on that, and the first one is ground. So we're going to get a ground, and this can actually go anywhere along this bottom wire. You just want to make sure that it makes that connection, so left click to drop that in. Okay, so now we have a completed circuit. This is ready to simulate, but if we don't put in any meters, we're not going to be able to collect any data from our simulation. So let's do that. Let's put in a voltmeter to measure the voltage drop across this resistor, and let's put in an ammeter to measure the current that's flowing through this loop. So over here on the left hand side, the first one with this green V is analysis and annotation. In this menu you'll see voltage. Let's grab one of those first. And I'm just going to drop this above the resistor. Now for a regular voltmeter, a voltmeter is probably going to have two probes. You're going to have a positive probe and a negative probe. And if you click on this V minus here, that is going to give you that negative probe. Okay, so we have this reference probe that I'm just going to put below the resistor. So now what this is going to do, it's going to measure the potential difference between the probes here, between these two leads. And so that's going to give us the voltage drop across the resistor. Alright, so I have my voltmeter in place. Now go back to analysis and annotation and click on current. So this is an ammeter. There's only one loop in this circuit, so the current is going to be the same everywhere. So I'm just going to put this ammeter along this top wire. Now it looks like this says I minus, it looks like this says V minus, but those aren't minuses, those are blanks, and that's because we haven't run the simulation yet. These are also named, so PR1 is the name of the voltmeter and PR2 is the name of the ammeter, and we'll need that later when we go to view our plotted data. So we're ready to run this simulation. To do that, you go up here to the top left, there's a play button. If I click that one time, that's going to run my simulation. I don't have to run this for very long because I'm just providing a constant voltage source. I'm not going to have any oscillations or any transients that I have to worry about leveling off. So I stopped my simulation by pressing this stop button, and now you can see that our meters are now reading, for our ammeter, we're reading 12 milliamps, and the voltmeter is reading 12 volts. Okay, great. So now if you want to look at the plotted data, you click on this grapher tab up at the top, and that's going to show you the plotted current and voltage that we just measured from our circuit. So if you see the axis here, we've got voltage on the left-hand side, and it's hard to see, but the green and the blue curve are actually right on top of each other because of the axis over here on the left-hand side is voltage in volts, and over here on the right-hand side is current in milliamps. So if you want to save this data, you go up here to this 3x3 square dots, and if you go to export and export grapher image, that is going to save a PNG of this plot. And then same story over here for your schematic. If you'd like to save a copy of your schematic to include in a lab report, go to export and schematic image, and that will save your PNG. So when you go to do this lab for yourself, try practicing going over here and finding the components that you want, drop it in, put in all your connectors, make sure you have your ground node, put in your meters. You can double click on all these values to change resistance values and current voltage source values and run your simulation. And good luck!